How you going, guys? Kurtis from Cutting Edge Engineering. Today's job, we're going to be moving the hand wheel for the carriage on the Megabore. And we already knew before we built and installed the platform that the height of the hand wheel was going to be a problem, and we'd already made a plan on how we were going to relocate it to make the machine a lot more comfortable to operate. And after having a good look at it, we quickly decided, without overcomplicating it, the best and easiest way to do it was to use the original output shaft of the carriage, which already has the reduction for the fine adjustment. And what we're going to be doing is making a new mount assembly for the hand wheel, which connects to the drive shafts through a chain and sprocket. So I don't have a drawing for this, but I do have a general idea on what I want. I've got the materials that I think I'm going to need, and I don't want to drill and tap any new holes in the carriage, and we'll just deal with any challenges if they pop up. So we're going to get started by removing the hand wheel.
Ta-da!
So that's the hand wheel off. Now I'm going to remove these two bolts because we're going to use those bolt holes to mount the assembly.
Why? What was wrong with that? Ooh.
Because this is a rough casting and this top surface hasn't been machine true, I'm not going to bolt anything directly onto that. What I'm going to be utilising is the pockets of the bolt holes because they are machine true. And I'm going to start by machining up some spaces that go in there, and that will be a reference point for the rest of the build. And to make the spaces, we're going to be using a piece of 1045 solid bar. So I need the space here to be 32mm in diameter, so I'm going to machine 3mm off the OD. And to drill the clearance hole for the bolt, I'm going to use a 20mm cruz drill. Now we're going to part this to length, and I've already worked out based on the length of the bolt that these need to be about 56 mil long, and that's going to give me a little bit of room to machine them down if I need to set the tension on the chain. So that's our first spacer made, and it fits perfectly. Now we're going to make the second one. Now with those done, the next thing I'm going to do is make the mounting plate, and we're going to be using a piece of 8mm flat bar. It is 100mm wide, and I just need to cut it to a length of 250mm. And I'm just going to use my radius master to radius two of the corners. Now we're going to get it set up in the mill so we can drill the bolt holes. So I found center, and we know the distance between the centers of the bolt holes is about 171 mil. So I'm going to move the table across half of that, which is 85.5 mil. Now I'm going to offset off the back of the plate 30 mil, and that is taking into account half of the diameter of the edge finder, which is going to put our hole 25 mil in from the edge, and that will allow enough room for our washer to sit on the plate without hanging off the back of it.
Oh, how good's that?
Now we need to make the spindle that is going to be welded onto that plate, and we're going to make that out of a piece of 75 by 45 mil hollow bar. And we're going to cut it to a length of 250 mil to match up with our plate. Now we need to do some machining in the lathe, and we're going to start by turning 10 mil off the OD to reduce some weight. Now we need to counterbore each end for the bearing, and the diameter of the bearing is 55mm, so we're aiming for an ID of 54.98mm. That's measuring to within 0.2 of its finished diameter, so I'm going to slowly creep up to it so I don't overcut it. So that's going to be a light interference fit where I'll just need to tap it in with a hammer, but now we can flip it over and do the same to the other side. So that's the machining completed on this. Next thing I need to do is weld it onto the plate. Not enough support there. No. Not happy with that. So after having a look at that and sitting the spindle in place and then bringing the hand wheel up to where it's going to live, I'm not happy with how much of the inner shaft is not going to be supported, and I don't want to run into any dramas, so I'm going to make up a new spindle 100mm longer. And because it was the exact same process, I've already gone ahead and got that made.
Yeah, okay.
So I'm much happier with that. That's going to offer a lot more support to the inner shaft. Now we can remove the plate and get these welded together. So to weld this up, I'm going to do one weld on each side, and I'm not going to weld the first 20mm because I don't want the heat to affect the fit on the bearing. Now that's done, we can install the bearings. And what we're using is an FAG ball bearing. They are pretty good quality considering they are quite cheap and they are readily available from all of our local bearing shops. Righto guys, so that's our spindle housing completed. Before we go and make our inner shaft, I am going to bolt this onto the lathe and then we can take some measurements and that way we know how long the shaft needs to be. And to calculate that, we add the length of the housing, the width of the sprocket and the hand wheel, and then we measure the offset between the end of the spindle and the shoulder on the output shaft. And all of that added together ends up being 420.3 mil, which is the overall length of our shaft. Now we can get that cut and start machining. We're going to start by machining the length that goes into the housing. We want it to be a nice, neat slip fit into the bearings, so we're going to machine it just under 30 mil. And next I'm going to drill and tap the end for an M8 bolt, and that is going to be used to retain the shaft in the housing. Now we're going to flip it around and machine all the details on the other end for the sprocket and the handwheel. So that's all the lathe work completed on the shaft. The last thing we need to do is mill in the keyway, and it needs to be 8mm wide by 4mm deep. But first, we need to find center. So that's a shaft done. Now we're going to go install it in the spindle. So that was a nice neat fit, that was spot on exactly how we wanted it. Next thing we need to do is machine out the sprockets and broach the keyways.
Whoa.
And to broach the keyways, we're going to be using an 8mm keyway broach and a 32mm plug in the hydraulic press. Another option would have been setting up the slotting attachment on the Zaya, but that is a lot more effort and would take a lot more time. And when using a 150 tonne press, you don't have any feel at all. It is very easy to bend and snap a broach. So what I do every inch or so is relieve the pressure and allow everything to come back into alignment, and then I continue broaching. So quite often when I'm broaching in this press, I often find that it overcuts the bottom of the keyway. So halfway through the job, I'll turn it up the other way so I can level it up.
Cool.
So the next thing we need to do is drill and tap the holes for the grub screws to lock the sprockets onto the shaft. I prefer to drill and tap the hole down through the keyway, that way when I tighten the grub screw, it doesn't damage the shaft. And now we've got that done, we can fit them to the shafts on the carriage. Now with that done, we can fit the chain. In order to get the correct length and the tension, we may need to adjust the spacers underneath the spindle. Join the link?
Mm-hmm. Too loose.
No. Need to be able to. Hang on, let's bring it back the other way. We're not far off. So that's too loose as it fits now, but we're not far off getting it to the next link. So what I'm going to do is pull it apart and machine 1/2 mil off each spacer. I'm going to start with that. I'd rather take off little bits each time rather than take off too much and have to adjust everything to the next link. So that wasn't quite enough. I'm going to take off another 0.2 of a mil and see how that goes. So that fits spot on. Now we can separate the chain and test this out properly. Righto guys, so that fits on there perfectly. Everything is working exactly how I want it to. There is a perfect amount of tension on that chain and everything in the assembly is moving freely. The carriage travels forward and back with no problem at all. It is at a much more comfortable height and is much easier to operate. And I'm very happy with how that's turned out so far. The next thing we need to do is make the guard to cover the chain. So obviously we need to make the guard up for safety because a chain and sprocket can do a lot of damage, but we really do want to protect the chain and sprockets from swarf getting in there, because if I'm rapid traversing the carriage and a bit of swarf gets in between them, I could definitely bend the output shaft on the carriage. So normally I would like to have this drawn up, laser cut and pressed into shape, but unfortunately we didn't have the time on this one. So what we're going to do is see what I got laying around the workshop and see what I come up with. And what I've decided to use is this old tray. It is made from 2mm thick material and it is coated in zinc. I do have a few of them left over from a previous job and I have found them quite handy to use. So that's the cover fabricated. Next thing we need to do is come up with a mount to hold this in place. So what I'm going to be using to make the collar is a scrap piece of 80 by 60 mil hollow bar, and we're just going to machine that so it fits over the spindle and can be tacked to the back of the guard and locked in place. And while I'm at the lathe, I'm going to machine up 2 spacers, and they'll be used to hold the front and the back of the guard the correct distance apart. I'm also just going to quickly drill and tap the hole in the collar for the grub screw. And now we can tack that onto the back guard of the cover. We're also just going to drill in the holes that bolt the two covers together and tack in the spaces. And now we're going to put everything back together to make sure everything fits, and then we can paint it. So the guard fits pretty well. There is enough clearance around the chain and it's not touching the guard, but I'm not quite happy with how everything's meeting up here. So I'm going to do some panel beating off camera and then I'm going to get it painted. To paint this, we're just going to be using spray cans and we're going to start with a grey etch primer. And the top coat is going to be a dual lux flat white.
Oh. Oh no.
So, no drip technology. Righto guys, that's the mount assembly and the relocation of the handwheel completed, and that is a massive improvement from where it originally came from. The original center of the handwheel was at 310mm, and now we've relocated it, it is at 670, so we have gained 360mm. And considering I'm over 6 foot tall, that is a great improvement. And I'm really happy with the location of where we decided to mount it. It is right beside the handwheel for the cross slide. Not only is it going to be a lot more comfortable, it's going to be a lot easier to operate. And it doesn't sound like the chain or the sprocket is touching the guard when we're moving the carriage by hand, but to make sure all of this is working correctly, I'm going to rapid traverse the carriage back and forward. And the cost to build this came in pretty cheap because the main materials we needed we already had in stock and they were laying around. What we had to buy was a chain, that was $50, the sprockets were $15 each, the bearings were $9 each, and there was about $20 in hardware, and also $18 for a tin of paint. So all up we spent $135 and it was about a day's work, and if I was to do it again, the only thing I would change would be getting the guard laser cut and folded so it fit a little bit neater. But all in all, I'm really happy with it and we hope you enjoyed the video. Thanks for watching. It's a bit of weight to it. Oh, she put a nardy on it.
Oi.
Oi.
Do you have one?
No.
Dang it.
She put a nardy wheel on.
That'd be sick. You're so short. Hey, it can be unbolted.
Ready? It's been too long. So that fits perfectly. That was a very nice, neat fit. That is absolutely fucking... So that's the handwheel off. Now we're going to remove these top two bolts and we're going to be using that location. Now we're going to part this to length. I'm going to make it 56mm long. So I'm much happier with that. That means that shaft is going to be supported and it looks a lot better too. I didn't like that.
Isn't that automatic?
Yeah, that's jamming.
Oh. This thing needs a...
It needs some love.
Yeah. Frickin' heck.
That's the bad thing. This is really...
Painful. Yes.
Well, fucking help me. It's in there.
Oh.
What the fuck happened there? Damn it. Oh, what the fuck?
You good boy. Wee.